Hello, this is a video on how to do limiting reactant problems. By this time, you should have printed out or opened up the limiting reactant handout, which is under the notes, and two additional work ones. One where it says, you're going to be looking at stoichiometry periodically. One that looks like this and another that looks like this, and they're both basically the same thing, and we'll talk about that in a second. So the first thing is you should have read this already. So it's a lot of work, and if you don't have to do it, you don't want to do it. So the first thing you need to know is, when do you have to do a limiting reactant problem? And the answer is, if they give you information about both reactants. That's when you have to do a limiting reactant problem. And the reason is you don't, since you're going to be doing stoichiometry, and stoichiometry requires a starting point. If you're given information about both reactants, which one do you start with? Do you start off with the information from the first reactant or the second reactant? So you have to figure that out. So that's what's called a limiting reactant problem. So if they don't give you information about both reactants, let's say they give you just information about the products, or they give you information about one reactant and don't say anything else about another reactant, the assumption is that the other reactant has as much reactant as needed so that the information they gave you can occur. So if that's not the case and you're given two information about both reactants, the first thing you must do, what's going to happen is one's going to run out first, and that's called the limiting reactant. And that limits how much of the product you make. And the other one is called reactants in excess, or just in excess. So these problems are exactly like any other stoichiometry problems. Again, the only difference is you have to first figure out which of the reactant runs out first, so that's the one that's going to determine how much products you make. So that's why I have this one. You should be able to go back in your notes and take a look at this. These are the steps of stoichiometry. And if you look at this in the steps of stoichiometry, there's the stoichiometry notes handout. And if you look and you go through it, what you see is you must have a balanced chemical reaction. But the second thing is you're going to convert the known information units into the moles of those information. Well, that's why down here it says under B, we'll modify this step when we're doing limiting reactant problems. So a limiting reactant problem is no different than any other stoichiometry problem, except for you first must find which of the two reactants is the limiting reactant before you do anything else. So the steps, again, balanced chemical reaction, and this is the second one. This is the one I'm going to modify. So now we have to figure out which one is limiting. Okay, so you convert your known information about both of them into moles. Okay, so I'll get you one of the examples up here. So here's an example. This example here is exactly like this example here, except different typing. So in this one, we're changing. They gave us information about oxygen and hydrogen chloride. So of course, we're going to change the grams of oxygen into moles of oxygen using mole mass calculation. And same thing with grams of HCl into moles of HCl. Okay, that's what those two numbers are. And above is the information that you need, molar mass calculations. Now the question is, which one's going to run out first? Okay, and if you're lucky enough to do the demonstration, we talked about this, the limiting reactant demonstration. So what you're going to do is you're going to assume one goes to completion. So in this case, we're going to assume that O2 goes to completion. Does it make a difference? No, it doesn't make a difference which one you assume. Okay, and that's why I have two different examples here. So this one assumes oxygen goes to completion. So what you want to know is how much HCl do we need to get rid of all the O2? And that's what this calculation is. We know that in the chemical reaction, using the molar ratio, that it takes, for every 1 mole of oxygen, you're going to need 4 moles of HCl. So if you have 0.8062 moles of oxygen, then you're going to require 3.225 moles of HCl is needed to completely react all the oxygen. So therefore, the question is, do you have enough? So you compare the 3.225 moles of HCl that you need to get rid of all the oxygen, and you realize that you only have 1.767 moles of HCl. So what happens is you don't have enough HCl. So it's not the oxygen that is limiting, it's the HCl. So you're going to have to say this. So since we need 3.225 moles of HCl to completely react all the oxygen, and we only have 1.7675 moles of HCl, then the HCl must be limiting because we don't have enough of it to get rid of all oxygen. So HCl is limiting. And I expect you to write this whole thing right here. So in essence, what we're going to do is we're going to use the HCl reactant information in our stoichiometry. That's our starting point. Okay. Now, this is the same exact question or example. The only thing here is I didn't assume O2 goes to completion. I assumed HCl goes to completion. Okay, so this would be the other assumption you made, and I want to show you it. So in this one, I assume HCl goes to completion, same molar ratio, just inverted, and it would only take 0.4417 moles of oxygen to react all HCl. Well, how much O2 do we have? Well, we have 0.8062, so we have enough. So therefore, that also justifies you to say that HCl is limiting. Okay, so you would have to say it again, since we need 0.4417 moles of O2 to completely react all the HCl, and we have 0.8062 moles, and HCl is limiting. You can see from both of the ways of doing the same problem, we get the same limiting reactant, and that HCl is limiting. Okay, and I want to show you both assumptions so you could see that it works either way. Okay. From this point on, whenever we do stoichiometry, we're going to use the HCl information. So the second question, so the first question is which one's limiting? So the HCl is limiting, and of course then the O2 is in excess. So the next one is give me the mass in grams of the two products. So we're going to have Cl2 and H2O as products. So therefore, that is two separate stoichiometry problems. Of course, they both start with the limiting reactant. Everything always starts with limiting reactant. So you change the moles of HCl into the moles of Cl2, and then we know that the molar ratio, molar mass of Cl2 is 71 because you did a little calculation over here, and you got 62.74 grams of Cl2. And then they also want H2O, so you do the same exact thing. Different molar ratios because, of course, the coefficients are different. Oh, actually, in this case, they're the same, but they most likely can be different. And then you get 15.9 grams of H2O. Okay? And if you did it the other way, if you made the other assumption, what you will see is the fact that they're the same exact calculations in the product part. So you're doing both of the same things. Okay, and then the last part is how much of the in excess material is left over, and that's always done by initial minus reacted is equal to leftover. You know initially how much you have because that's the first thing you calculated up here, the initial amounts of both reactants. Now the question is, how much reacted? Well, again, that's part of the chemical reaction, so we're going to start off with the limiting reactant problem information, limiting reactant information. So we have this many moles of HCl because that's how much we said we have, and that's all being consumed. And we want to know how much oxygen we reacted. So set up the molar ratio. You have 0.4418 moles of O2 reacted. Okay. So this is how much was consumed. This is how much initially have. So you have this many moles left over. So of course, then you change your moles of O2 into grams of O2 to get how much is left over. Okay, and again, doing it the other way is the same exact information. Okay, you can, if you want, another way of doing this is changing everything into grams and then do the subtraction. Okay, and that's the most common type of limiting reactant problem there is. Again, besides determining the excess reactant information, the problem is a stoichiometry problem. Again, the only time you do this is if they give you information about both reactants. Because as you know with stoichiometry, you have to have a starting point. And you don't know which of the two reactant information is the starting point. You have to first figure that out. And that one will be called the limiting reactant. And that limiting reactant will be all the to do any of the calculations. That's what you start with when you're doing stoichiometry. And the other one is an excess, and there should be some left over. Okay? Very infrequently, and you usually don't do it with these types of problems, but is there a time in which they both of the reactants run out exactly at the same time? Yes. That's called stoichiometric amounts. When somebody says something in a problem that you have stoichiometric amounts, what that means is that they've designed that problem so that both reactants are consumed, or both reactants are done exactly the same. Okay, so there is no excess left over. Okay, I hope this helped, and if you have any additional questions, you can look at this again. Okay, and the directions are written down in here. Okay, in this handout. So the directions down here are what I just talked about. Okay, thank you very much. Have a good day.